Gemini 3.6 Flash cranks out 209 MOIGs tokens per second, ranked third out of 185 models, and OpenCode can run it for free. Both of these just dropped, and I'm putting them through 5 head-to-head tests to figure out what actually wins. One of them isn't even a model, and that changes the cost math completely once you get to the verdict. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. And every number here is traced back to official model cards, vendor docs, and artificial analysis benchmarks. If you're running coding agents at any real volume, the model you pick and the harness you run it in can swing your monthly bill by hundreds of dollars, and most people don't notice until it's already hit. Test 1. Cost. The number itself is the story. Gemini 3.6 Flash is $1.50 per million input tokens and $7.50 per million output tokens. So if you're pushing 1 million output tokens a month and you pick the wrong pricing model, that gap shows up on your credit card before you even realize it. OpenCode has a free tier, $0. That changes everything about how you think about getting started. So what I found here is pretty interesting. Gemini 3.6 Flash charges $1.50 per million input tokens and $7.50 per million output tokens, with a cash discount down to 0.15 per million, which is 90% off. OpenCode's Go plan is $10 a month, and there's a free BYOK tier at $0. These are genuinely different cost structures, so keep that in mind going in. The gap here is a little misleading because you're comparing a per token rate to a flat subscription, and at 1 million output tokens, Gemini costs $7.50, while OpenCode's Go plan is $10 a month total. But OpenCode doesn't generate those tokens itself. It just routes them through whatever model you plug in. So the real cost of OpenCode is the subscription plus your model's API bill, and they're just not the same kind of thing. Cost is a tie. They're priced in completely different ways, so you can't score it clean. Gemini 3.6 Flash wins on per token efficiency with that cash discount. OpenCode wins on free tier access, and neither takes the point. That's 0 for Gemini 3.6, 0 for OpenCode, 1 tied. Test 2. Coding benchmark performance. The Artificial Analysis Intelligence Index median sits at 32, and that's the number you need to beat to be above average across 185 models. If your model scores below that and you're running it on production code, you're paying for a tool that's going to hallucinate more and fix less. The Deep SWE score is the other one to watch here because it measures real software engineering task completion, not just trivia. Gemini 3.6 Flash scores 50 on the Artificial Analysis Intelligence Index, well above that 32 median, and on Deep SWE, it went from 37% to 49% while using 65% fewer output tokens compared to the previous Flash model, which honestly surprised me because that kind of efficiency jump is not what you usually see alongside a quality improvement. OpenCode has no score here at all because it's the harness, not the model being scored. Gemini 3.6 takes this one. A score of 50 against a median of 32 is a real gap, and the Deep SWE jumped from 37% to 49%, with fewer tokens is the kind of efficiency you actually feel in your API bill. OpenCode has no benchmark score because it's not a model, so that puts Gemini 3.6 up 1, OpenCode at 0, 1, still tied. Test 3. Speed. 2, 19.6 tokens per second, third out of 185 models. If you're running an agent loop that fires dozens of completions per task and your model is slow, you're not just waiting longer, you're also paying for more wall clock time on your infrastructure, and slow models compound fast at scale. Gemini 3.6 Flash measures at 219.6 tokens per second, third fastest out of 185 models on artificial analysis, and that's a hard, verified number. OpenCode speed is whatever model you're running through it on whatever hardware you've got, so there's no fixed figure. And community reports show it can get really slow with large context snapshots. One case had a 16 gigabyte snapshot file, with replies taking 5 minutes. Take that with a grain of salt since it's community reported, but it's worth knowing going in. Speed goes to Gemini 3.6. 19.6 tokens per second, with a verified rank of third out of 185 is a concrete win. OpenCode speed is a variable, not a stat, and the reported slowness on large snapshots is a real risk. Gemini 3.6 now leads 2-0 with one tied. Alright, so Gemini 3.6 is ahead on the scored tests, but we still haven't looked at context limits and deployment flexibility. And those two dimensions are where the model versus harness split gets really interesting, because if you're working with massive codebases or need to swap models on the fly, the next test could completely change which one fits your actual workflow. Test 4. Context and output limits. 1,048,576 tokens. That's Gemini 3.6 Flash's native input limit. And if you're indexing a large monorepo and your model's context ceiling cuts out halfway through, you're getting incomplete analysis and bad refactors. And by the time you notice, starting over is already expensive. Gemini 3.6 Flash has a fixed 1,048,576 token input window and a 65,536 token output limit, both set by Google. OpenCode doesn't have fixed limits at all because it passes through whatever the model you're running supports, and its config schema lets you set context and output limits per model. What I didn't expect is that flexibility here is actually a feature, not a gap, because you configure it to match whatever model you plug in, rather than being locked to one ceiling. Context and output limits is a tie. Gemini 3.6 Flash brings a massive native 1 million token window, and OpenCode brings configurable limits that flex with whatever model you're running, so neither one beats the other cleanly because they're solving the same problem from different angles. Score stays at Gemini 3.6 2, OpenCode 0, now 2 tied. Test 5. Deployment and modality. 75 plus LLM providers. That's how many sources OpenCode can route through, including local models. And if you're locked into a single API and that provider changes pricing overnight, your whole workflow breaks. What you actually need to figure out is which layer of the stack you need to control to stay flexible. Okay, so this one is genuinely not comparable, and I want to be upfront about that. Gemini 3.6 Flash is a multimodal model handling text, image, video, audio, and PDF input deployed via API through Google AI Studio and Vertex, while OpenCode runs in your terminal, your IDE, or on your desktop and connects to 75 plus providers including local models. These are different layers of the stack entirely, and I couldn't find a fair way to score this head-to-head. Deployment and modality is a no-winner call. Scoring this one would just be fake because these two tools don't compete at the same layer. Gemini 3.6 Flash is the model, OpenCode is the surface that runs it, and the final tally sits at Gemini 3.6 2, OpenCode 0, 3 tied or not scored. So where does Gemini 3.6 clearly pull ahead? Raw speed at 219.6 tokens per second, third out of 185 models. Benchmark performance with an AA intelligence index score of 50 against a median of 32. A deep SWE jumped from 37% to 49%, with 65% fewer output tokens. And a native 1 million token context window you don't have to configure. These are hard numbers, not vibes. Now where does OpenCode clearly pull ahead? Free BYOK tier at $0, since Gemini 3.6 has no free tier at all. Model agnostic routing across 75 plus providers including local models. Configurable context and output limits per model so you're not locked to one ceiling. And it's open source, which means you can customize it however your stack needs. Alright, so here's the honest take. I went in thinking this would be a clean model versus model fight, and what I got was a model versus the thing that runs models. If you need raw performance, 219.6 tokens per second, and an AA index score of 50, pick Gemini 3.6 Flash. If you need control over your stack, zero cost to start, and the freedom to swap models across 75 plus providers, OpenCode is your answer. You probably end up needing both. If you want to see how a free local stack actually holds up against a paid coding agent, I did a full breakdown called Allama versus Claude Code, and the result is way closer than you'd expect. Check it out next.